Thanks for introducing yourselves. My name is Meg Ray. Right now, I'm an independent contractor, but I'm affiliated with Cornell Tech, as well as Hunter College and NYU. And my day job is doing PD and coaching teachers in K-12. I'm also an author of a coding book for kids. I do educational research in CS education, especially related to students with disabilities. And I'm adjunct faculty in the schools of education at NYU and Hunter. And I'm also a toddler mommy, so that's my other connection to early childhood. So I had an icebreaker, but we already introduced ourselves, so that's okay. I think we'll skip it so that we can get on to everything and then have time for questions. But this is an icebreaker that I do in PD for teachers in early childhood and K-1. I ask them to share out, or we usually do a turn and talk. Turn and talk, what's one thing that you debugged today? It's usually getting to school. And then point out that one of the strategies that we want to do is to make new concepts familiar. So for this, I've done that in a couple ways. They actually all got a little cartoon bug to hold in their hands. So I'm connecting what a preschooler or a kindergartner thinks of as a bug with the new concept. I'm making a concept that we'll talk about abstractly more concrete, and I'm connecting it to their everyday knowledge by saying, oh, sometimes I have a problem in life and I know how to solve it. So that's just my opening example. So I'm going to start with preschool, and then I'll move on to some elementary stuff, and I'll actually share our scope and sequence with you. One of the schools where I coach, we established a K-8 scope and sequence. They have every single teacher in their school teaches computer science, starting in preschool, and they teach it once a week in the regular classroom. So it's been very fascinating because we started out with every child coming in as a beginner, regardless of age. And now we're 4 years in. So we have fourth graders with 4 years of CS experience, and we have to constantly update our scope and sequence and curriculum because the kids are always surprising us with what they're able to do with that much background knowledge. So I'll talk a little bit about that later. But let's start with preschool. Why would we start in preschool? Is it really necessary? It's probably not strictly necessary, but I think it's a great idea for two reasons. One, it develops an awareness of computing early on, which is ubiquitous in our society, and it lays the groundwork for future learning. So, awareness. Here's some examples. Teachers in the pre-K room have word walls. So here's a word wall for programmer. Here is a prompt that they use for a do now during rug time one day. And they let the students come up with their own definition of what a robot is, and then they defined it. And this is how they introduce using robots in class. Many of the kids get really excited because they have either seen or their family owns a vacuum or a drone. Okay, so, and that's the smaller piece, it's important. But the big piece is laying the groundwork for continued learning. We rely on the number sense that preschoolers learn in order to teach them kindergarten math and then first grade math and so on. And we rely on all of that to get to algebra. We don't start kids with math when it's time to start algebra. And that's essentially what we've done with computer science. They go into APCS, CSP or CSA, and we say, okay, you've had no background, let's do algebra. So we're looking at how do we create this pathway for that. And in pre-K and the younger grades, we don't really focus on the CS concepts from the K-12 framework. We focus on the practices. And we'll talk about how these connect later, but all of these, fostering inclusive computing, collaborating, communicating, all of those, we can connect with activities for preschoolers. And even we'll get to developing and using abstractions. And you'll be amazed at what they can do with that. The other thing that we're doing is building concepts related to computational thinking. So even though we talked about computers and robots in an example before, that's not the big emphasis. I don't really care how much they know about programming or data and analysis or the internet, those kinds of things, because the focus is on these two sets of skills and starting to lay the groundwork for those skills. So although I've been working with teachers in early education who are experts in that, I personally am not an early childhood education expert. So I will refer you to the supplemental material from the K-12 CS framework that was put together by a panel of experts in early childhood education. And that's what I use as sort of a foundation and basis for our work. So what you're seeing here is their model for early childhood CS. Everything is centered around play. And that's really developmentally appropriate for preschool. And everything has a social emotional learning component. Beyond that, CS activities are expanding what teachers are already doing in the classroom and their goals that they already have for students. And they're doing that by focusing on these 4 areas: recognizing patterns, learning to problem solve, understanding representation, and learning sequencing. So what does that look like? First, with play, just want to say that this is consistent with CS pedagogy across the board. So we have a quote from Coding as a Playground about the benefits of play. And then from Mitch Resnick about why it's appropriate for children to learn CS through play. So social emotional learning, this is where we're really supporting those practices around communicating, collaborating, and having an inclusive environment. So what does that look like? Well, one example is that we do explicit teaching around persistence. And what that means. We plan in time into our mini lessons to talk about emotions, to talk about how it feels when something goes wrong. We role play what happens if you build a block tower and it falls over. And one teacher acts really frustrated and the other teacher comforts them. We use a lot of clips from Disney movies. You know, what does this character feel right now? Can you tell us about a time that you felt sad? Tell us about a time that you felt frustrated. And then we talk about persistence and we practice it. We use the Just Keep Swimming song a lot because it's a nice, light way that then when we go into the activity, when a child does start to get upset, we can cue them by singing just a couple lines. And that usually is enough for them to self-regulate unless they have some other challenges going on. We also do things like reward. We actually pass out these bugs. When kids get a bug, or have like a bug in whatever they're doing, and they fix it, they get a bug card. And we reward teams who have the most bugs at the end. So we do a lot related to that. The other thing is we support collaboration. So we don't just tell students to go collaborate as you wouldn't in any subject area. So, there's a lot of methods that we use in computer science, including pair programming. But we found that even just explaining the roles and saying, do these roles is not enough. We actually give kids sentence stems or scripts so that they can learn how to collaborate effectively. So we might have a script for the navigator that says, like, if this is for programming, if the sprite isn't doing what the driver wants, these are the 4 questions that you ask. And then we also have some protocols where it's just sentence starters that they can pick from. And we do this until they don't need it anymore, until they feel more comfortable. And then they naturally start doing it on their own. So let's look at those 4 concepts for pre-K. One is patterns. We just want to develop this ability to find patterns, to create patterns, to use patterns. A great tool for that is called Pixel Blocks by Little Problem Solvers. They're just wooden blocks with a different color on each side, and they come with a curriculum as well as these little matching cards. So there are a lot of things you can do with them with all different concepts, but I find that pattern recognition is a great one for this. Okay, then we get to problem solving. So it's not too early. In pre-K and kindergarten and first grade, we can be teaching children how to problem solve independently, or even better, how to problem solve collaboratively. And it is a challenge. It is not easy to get, a group of kindergartners or preschoolers to talk together and do a task together. So we've done role cards, which we find preschool doesn't work, but we can start as early as kindergarten for giving them roles. We have a debugger, we have a programmer, we have an algorithm writer. They have to practice a lot, and so we practice as a class, and then they have to solve these activities on their own. We also do open-ended challenges. So we do the engineering challenge where you need to make the highest tower you can. Now in pre-K and kindergarten, one of the big struggles with that is getting them to understand we want a tall tower. They don't always work towards the goal. They're really excited about building. So we do a lot of prompting about working towards the goal, and the teacher does a lot of debugging with them. So when the tower falls over, the teacher comes over and says, what happened? What do you think we could do different this time? And then sometimes, especially pre-K, the teacher gives them an idea, but then they execute it. All right. Representation. So, I mean, at this age, especially pre-K students they're connecting what is representation in general. They're learning the alphabet, right? Which is a form of representation. So actually I want to show you this one first. So we have a process for learning how to make algorithms and program. We start with physical directions. So I would stand here as the teacher and I would actually do the motion and then the kids would do it. We call it programmer says. They're computers and the teacher's the programmer. Once we move from actual physical coding, we also have the students like point in a direction and then they program another student to walk the way they're pointing. Once they master that, we move to arrow code, which is very similar to what they're physically doing. We're just doing it with the arrows. And at that point, we move them on to a coding platform that doesn't need reading. So Scratch Junior here, but there's several others. And then they move on to Scratch after that. So we found, so they do a lot of paper programming. If you've heard of Meet the Flurbs, which is a code.org unplugged activity, they're basically moving this pirate along a piece of paper following arrows to get to the treasure. So they're doing a lot of that. They do this in pre-K. Now in pre-K, you can see, oh, you can't because it just looks like a strip. In pre-K, so imagine that pirate code is on a grid. They actually draw the code right onto the grid. So it's that shape. Then the next step is that they have a mat, an algorithm mat that is just blank squares. And they start making the algorithm not on the grid, but on the mat. That's a big jump for them. But as you can see here, these kids are using a cubeto. Now, we had started kindergartners on a Bebot. Bebots have, they go in 4 directions and they have arrow buttons right on their back. So you could lay out your algorithm, press the arrows, and it will go however you say, in whatever order the arrows you press. Now, we also bought a cubeto to use for station work in pre-K. I'll show you what a cubeto looks like fully in a moment. But as you can see, so they're coding with shapes on this board here. This board is not the robot. And each shape is a different thing. So it might be a direction. They actually have the ability to create functions on here. It might be a loop. And we found that preschoolers were doing more advanced abstraction work than kindergartners, because we gave kindergartners the Bebot and we gave preschoolers this, the cubeto, and the preschoolers were able to figure out what the different symbols meant, code them on this separate device, and then start doing things like using the function feature, using the loop feature, which the Bebot did not have. So they really surprised us with what they are capable of. They do, so we use the cubeto in small groups doing station work so that they have 3 to 5 preschoolers with a teacher or teacher's aide. And they rotate through. They take turns during station time with who gets this station, and they each get it once a week. So because of that, we actually amended our kindergarten scope and sequence. Sequencing, this is a big one. This is so easy to tie in with what teachers are already doing. So the first is having students create algorithms. So here's an easy one we always do. Create an algorithm for washing your hands. For preschoolers, we might give them this set of pictures and they would put them in order with a partner. For an older child, we might have them draw the steps. Teachers really like to do this with classroom routines. They have their class together come up with what is our algorithm for going to lunch? What is our algorithm for coming in the morning? Those sorts of things. And they have the students create it and then they make it into an anchor chart a lot of times. It also ties in really well with math and literacy. So here you can see us using a mouse robot, which I don't recommend because they break very quickly. But we use a mouse robot. So here in pre-K, they just had to program the robot to go to the number 10. The other numbers are there as distractors. In first grade, they did the same thing, but they did skip counting. So they had to go in order by the number they're skip counting. We've also done this aligned to the Teachers College ELA curriculum. So over here we have a nursery rhyme. During a nursery rhyme unit, Mary Had a Little Lamb. They learn about beginning, middle, and end. They put the story in order, or they put the story like around the mat. And then the students need to figure out how to get the mouse to each point of the story in order. Other connections that we've done are they've written a how-to script for how to use the mouse robot. That's a big emphasis in kindergarten teachers college. And we've also done science. So like, what are the steps of what is the life cycle of a caterpillar? Now let's do that in order. Okay. I was just looking at the chat to see if there's anything I should address. Okay. See if I can. Okay. Here's some robots I like, tools I like for pre-K. So Scratch Junior's in there, the B-Bot's there. I love the Cubetto and I love the Kibo. The Kibo's probably my favorite, but the Kibo is one of the most expensive robots on the market. The two drawbacks, it's the reader for the code, the scanner is finicky, and it's very, very expensive. However, the reason I like it is because, so there's an organization here in Brooklyn called Sunset Spark. They have an amazing pre-K curriculum with Cubetto. Cubetto, you put the blocks in order, like in a little chain. And what they do is they come up, they might have the blocks in order, like start, go forward until the light turns off, then stop. They would take those blocks and they would tell a story. So in one particular story, the child is afraid of the dark, so he stops. So they show the blocks in order as they tell this story. Then they send all the kids back to work in table groups. And they do the first code that exactly like they've been taught, and they remember it because of the story. And after they do that, they start remixing it on their own. And it's really amazing to see preschoolers doing table work in groups and doing kind of exploratory work. You never see that, and that wasn't in a school that was like a fancy private school, but in a Title I school here in Brooklyn. Here are some great books for preschoolers. Some of them say the word baby, so it's hard to use with preschoolers, but they're actually really good for preschoolers anyway. And then I've linked, I'll share this with Diane so she can share it out to you, because I've linked all the resources that I've used for that. Okay. I'm going to show you the scope and sequence. So this is the 4th year of computer science for every child at this school. And this is our sort of curriculum map for what we do. And it doesn't cover, this one's less detailed. So it doesn't cover, for example, the different programming concepts that are leveled for each grade. But so basically so pre-K is not on here because they do station work. They do the paper coding, they do that unplugged coding each other, programmer says, and they do the Cubetto. That's it. And they do it all year and they rotate in stations. Then in kindergarten, we get a more structured curriculum. So they start with unplugged, they start with Hello Ruby activities. They talk about what the internet is and what's inside a computer and those sorts of things. Then they do code.org, and they do it together. They sit on the rug together. The teacher puts it up on the smart board, and she talks about it, and she calls up different students to move the blocks. DC is digital citizenship. they get digital citizenship in technology class. So this is just what they do. They get it all year round. This is just what they do with their primary classroom teacher. Then they start robots. So like I said, we used to use Bebot, and now we've transitioned them to Kibo. Actually, the school was able to purchase some Kibos, but I would say without that, I would say Bebot. Another robot that I didn't put on here because it's not for preschool, but I like it, is an Edison. As long as they're able to do Scratch Junior, they can start with an Edison. They have a Scratch Junior interface, a Scratch interface, and a Python interface. So it can really grow with the kids, and it's the cheapest education robot on the market right now. It's $50 a robot. Okay, and then in kindergarten, you see in April, it overlaps because what they're doing is they're doing Scratch Junior as a station so that the teacher can work with small groups of kids. We found that it was just too difficult in kindergarten to instruct the entire class and have them follow along on that coding platform. And then they also have their math integration, which we talked about. And then I'll just go over first and second. So we always start with Unplugged. They have different topics that they cover so we don't overlap. First also does code.org. We kind of see code.org as the explicit teaching piece. We do the direct instruction with code.org, and then as soon as they're done, we move them on to project-based learning. They do their digital citizenship. They have an open-ended project in Scratch where it aligns to their ELA unit, where they're learning about realistic stories, something like that. And so they create one using Scratch Junior. And then they go on to robots, which they're using Bebots, which are also extensible, and they use the app. Oh, and their robots are aligned to social studies. So they work on community helpers. They learn about the different jobs in the community, and they create a little town and then steer their robot around in there. And they do the skip counting. Second grade starts with robots and is open-ended. They're also social studies. They're learning about landmarks. Then they get into code.org and they do a Scratch project, and they end with Makey-Makeys. So I'll stop there, but you can, again, I'll share this. You can look at the rest of them. Okay, at this point, hang on, I want to find out from you what you want to hear next. So,
You've got a couple questions, Meg.
Okay.
How much time a day or week is devoted to CS in your primary grades?
So it's an hour or one period a week. So 50 minutes, I would say 50 minutes a week. And it's, like I said, it's taught by the teacher. There is a lot of PD because the school has committed to every teacher teaching this. So what they do with that school is they do a 2-day summer intensive every year. And then throughout the year, once a month, they do a PD, but it's their after school time PD. It's a 50-minute once a month PD. And then they have a coach. So I used to be the coach there, but now they have somebody else. They have a coach who rotates through working with the entire staff, which is a huge job. And then they're grade team leaders. So what happens now is the coach focuses in on grade team leaders, and they turnkey to the rest of their team. Okay. I'm just looking at so the PD is ongoing, I would say, although it's not huge in volume.
How big of a school is it, just out of curiosity?
They have three to four classes of 30 kids per grade in elementary. So not huge, but not tiny. They're the partner school for Cornell Tech. So, any other questions about anything so far? Okay. So next, I have two things that I could do. The first thing is talking about teaching coding to students with disabilities in elementary and middle school. Or I have a little piece on like making online learning accessible.
Do you want me to put up a vote poll?
Yeah.
For the online learning, is it focused on computer science or is it just online learning in general?
No, it's just in general.
Oh, then just do the disabilities.
Okay, got it.
We've had lots of sessions on online learning going on.
Great. I'll do a little blend. I'll do my, here, let's see.
Killing the poll, don't need it.
Okay. Let's see if I can. 1 second. There we go. Okay, so here's where I'm going to jump around.
Are you using the curriculum for CSNYC? Or do you have your own for that school?
So the teachers develop it by modifying code.org, the CS for All curriculum in New York City, and sort of other sources that we like a lot. Like they adapt for barefoot computing, things like that. Okay, so now for something different. You can ignore the, so I want to talk about accessibility and teaching coding to students with invisible disabilities. So I don't know a lot about accessibility for students with low vision or who are deaf or hard of hearing or who need physical accommodations. But my research is in supporting and teaching students with these types of disabilities. So invisible just means that when you first meet somebody or on a kind of surface meeting, you would not know that they had a disability. And so when I say that, these are some of the things I'm talking about. So, you know, a great way to think about this as a teacher is rather than what does my student struggle with, which we always talk about and we always will continue to as teachers, starting to reframe that for ourselves and saying, okay, and then what's the limitation that my curriculum or my physical classroom or this tool is posing? And sort of flipping that question, because that gives us more control. We don't have control over what a student struggles with, but we do have control over limitations to our curriculum. Oh, this is for the accessibility part for online. Okay, so here's some evidence-based strategies for all students, but that are particularly effective for students with disabilities in K-8. So the first, here's where I'm going to jump around to. This is a process for introducing new concepts. So you start with defining the concept, then connect to their everyday understanding, role play the concept before looking at any code, then introduce the code, and then have them go into creating a project that uses the concept. So I have an example of this, 2 examples that I mashed together. Okay. So first we define the concept. I have a Scratch example and a web development example. So for Scratch, maybe we're looking at the concept of input. So here's a definition I could give students. And then for the web development, we're introducing an HTML element. Here's a definition. Okay. Then we get to the connect to an everyday understanding. So what does that look like? Well, for the input, here's something that they're probably familiar with. Well, this is a dated picture. Maybe we need like a picture of a cell phone or something. But here's a picture that should be updated that then they would be familiar with. And can we find the inputs? Okay, we've had this experience of using these buttons every day or using our touch screen, right? For the HTML element, here's an everyday understanding of sort of how a tag functions. Okay. Then I move to role-playing the concept. So especially for elementary, doing hands-on activities, kinetic activities is the best way to go, having them act it out in some way. So this is a strategy to sort of simulate input. The teacher says, when I shout go, start this sequence, and then the students do the sequence. Or you could do one, so in this actually, this is what the teacher would do. And then you have the students go into pairs. One is input and one does the output. So when I tap shoulder gently, smile. Depending on the age, you can have them come up with them with approval. So how do you role play an HTML element? So there's a couple ways to do it. One way is to tag things in the classroom. So every student got 2 sticky notes and they had to go tag something in the room. So here you could see the clock is now an HTML element. There's a very similar activity called Tag Revolution, where you stand in a circle and you give students printouts of different open and close elements. And then they have to do, so there's like clap, open, clap, close, and everybody in between has to keep clapping until the game's over. And then you layer on more and more of these activities. It's pretty fun. So they've acted it out, they've done the role play. Now we're ready to look at the code. Now we have the prior knowledge to understand the code. So you can see here for the Scratch code, the input is labeled so that students understand the connection. And here for HTML, we're still unplugged. But here we have code blocks or HTML cubes that have tags on each surface. And students can do like a relay to put them in order, or a number of other activities. So this helps them to see the code and become familiar with it, but they're not typing yet. And then finally, we get to create a project that uses the concept. So in Scratch, we have them maybe make a game that requires inputs. And for HTML, they had to create a basic web page about their favorite artists in this case, where obviously they had to use HTML elements. Okay, let me see what else I have. Okay, so you know what? That's all I have except the accessibility stuff. So
Well timed.
Yeah.
Just exactly the right amount of time for questions.
Excellent. Perfect. And also here's my contact info. Please feel free to reach out.
Somebody's curious if anyone knows about Kubo, K-U-B-O. Do you know that one?
Is it Kibo, K-I-B-O?
No, K-U-B-O. New one. I never heard
I
of
have
it.
not heard of it. They should change their name.
Very similar. I'm going to stop recording.